Start. 11th standard chemistry, unit 14, in second volume, in volume 2. That is organic halogen compounds. Organic halogen compounds. That is namely halogens, haloalkanes, and haloarenes. In this chapter, just you are very clear about what is organic halogen compounds. Carbon. There is carbon. Here you know that halogens. This is carbon. Organic means carbon. Halogen means there is 70th group. That you know, fluorine, chlorine, bromine, iodine, astatine. This is 70th group elements. This carbon is directly attached to this fluorine, carbon directly attached to this chlorine, carbon directly attached to this bromine, carbon directly attached to this iodine. This all can produces organic halogen compounds. Organic halogen compounds. Halogen compounds. Namely, we can write CH3F, CH3Cl, CH3Br, CH3I. These are all called organic halogen compounds. Generally, that you see here, the fluorine is directly attached to this carbon atom. Now, this compound form is called organic halogen compounds. But now in this session, we are going to study about organic polyhalogen compounds. Polyhalogen compounds. Polyhalogens. Organic polyhalogens. What is organic polyhalogens? Now you see that polyhalogens are nothing but the halogen atoms to be present in organic compounds. Organic compounds. That is many halogen compounds. Many halogen to be present. Many halogens or more than one halogen, more than one halogen to be present in the organic compounds are called polyhalogen compounds. Polyhalogen compounds. That organic polyhalogen compounds are classified into two types, namely, that is gem dihalides, and vicinal dihalides. Apart from that, there we are going to see two more examples of the compound, namely chloroform, you know that, and carbon tetrachloride. This is chloroform. Carbon trichloride. This is trichlorides. This is tetrachlorides. that you see here dihalides, that is dichlorides, dihalogens. Halogens are present. And here also vicinal dihalogens. There should be two halogens are present. Two halogens to be present. Di means two halogens. Di means two halogens. Two halogens are present in organic compounds, are called, we can say, organic polyhalogen compounds. So here in these organic polyhalogen compounds, many halogen compounds are present, many halogens, that is more halogens are present in a carbon atoms, more halogens are present in, more chlorines are present in carbon atoms. Two or more halogens are present in organic, that is carbon atom, is called, we can say, polyhalogen compounds. In these polyhalogen compounds, specially we are going to study about, that is Zem dihalides and vicinal dihalides. Zem dihalides and vicinal dihalides. Here, what is the necessary we have to study about these all compounds, which are all very important in this case of interstitial preparations of solvent, interstitial solvents, and many more drugs which are all to be prepared by using these compounds. Especially, you come to know that chloroform is the best anesthetic. Chloroform is the best anesthetic. And you can see that carbon tetrachloride is the best solvent for all organic substances. All the organic substances can dissolve into this carbon tetrachloride. It's the best solvent, the best anesthetic. So here it is that very essentially is it is very important for our medical field, and also that is in organic chemistry, and that is interstitial organic chemistry. So that's why we have to study about these all compounds and its preparations and uses and properties. Next we are going to see here what is the preparations of Zem dihalides. Preparation methods. Preparation of Zem dihalides. Preparation methods of Zem dihalides. First of all, we should know about that what is called acetaldehyde, you know. This is namely you have studied, you know, all over that organic chemistry. This is acetaldehyde is treated with, the first methods is treated with PCl5. The PCl5 is a chlorinating agent. Chlorine is added into this compound, that is chlorinating agent. This PCl5 can split into PCl3 and Cl and Cl. Now what happened here, that very clearly there is that containing two bonds you see here. This oxygen completely absorbed by this PCl3, now which come to as to be POCl3. Remaining what is here, two halogens are there. This one bond is attached with this one chlorine, another bond is attached with that another chlorine. Now the compound which is called, we can write CH3, then CH, then Cl, then Cl. That's a point you should understand. This is called Zem dihalides. This is Zem dihalides. In this Zem dihalides, specifically we can write the name ethylidene dichloride, and this is common name. And here that IUPAC name, you know that that containing two carbon, so it is called ethane. So it is called ethane. Now you write, see if in first carbon there should be the two chlorines are present. Now you write 1, 1, there is hyphen, dichloroethane. Is it IUPAC name? It's IUPAC name. That is that ethylidene chloride comes as a products, and that is plus POCl3 is formed as a byproducts in these chemical reactions. Now that is very clear about that. What is here we are going to see? What is called Zemdai halides and what is called vicinal halides. The Zemdai halides are nothing but, there is a definition for Zemdai halides. The chlorine atoms, now you take it CH3, CHCl2. The chlorine atoms are present in the same carbon atoms. Halogens are present in the halogen. Two halogens present in the same carbon atom. But here in vicinal dihalides, that is here I am going to give the example. You see CH2Cl, you see. Now in this case, now you write the structures for this compound, CH2Cl bond CH2C. Now in this structure, you can write it as in this form, Cl bond CH2 bond CH bond Cl. Either this mode or this mode, both are same in meaning. Now you come to know this is also to be the two chlorine atom present. Here see there is also two chlorine atom present. Now in this case two chlorine atoms are present in the, you see, vicinal dihalides. Two chlorine atoms are present in adjacent carbon atoms. Adjacent carbon atoms. Two chlorine atoms are present in adjacent carbon atoms are called vicinal dihalides. Two chlorine atoms are present in the same, two chlorine atoms are present in the same carbon atoms. Same, two halogens are present in same carbon atom is called Zemdai halides. Same carbon atom, Zemdai halides. Same carbon atom, what is the children? Same carbon atom, Zemdai halides. Adjacent carbon atoms, vicinal dihalides. So that we are going to see, there is several examples of Zemdai halides. Why I am coming to say this is that how these preparations are to be possible. And earlier to that, you should understand about what is called the Zemdai halides and what is called vicinal halides. That's why just I have given the preparations of these all compounds. Next, just we are going to see the next preparation methods. Next preparation method, the second methods. We are going to see that second method. That is second method of Zemdai halides. That is that acetylene. You know that CH, double bond CH. This is acetylene gas. This is the acetylene gas is passed into the hydrochloric acid. Now this hydrochloric acid is act as a one to be in a positive part, another to be a negative part. This double bond is the resonance. The double bond, wherever double bond or triple bond are present, double bond or triple bond are present, that will undergoing resonance. How far this resonance takes place? Now it becomes minus. The shifting of electrons. This is bond is nothing but electrons. There should be a shifting. If during the shifting of electrons, what will happen? One becomes negative part, another becomes positive part. Now this is also negative part and positive part. Now the compound which is formed is called, we can write, that is CH2 double bond CHCl. CH2 double bond CH is called, this is vinyl chloride. This is vinyl chloride. This vinyl chloride is only in this manufacturing of PVC pipe, polyvinyl chlorides. This is vinyl chloride. This vinyl chloride is again, it is treated with HCl. Now here also the same shifting of electron will take place, and here it is to be, the shifting will take place here minus and plus. Now here also there is a plus and minus. Now the halogen again it is coming to this hydrogen. This is the hydrogen. The halogen again it comes to this hydrogen. Now what happened here? The halogen, again it is coming to here. Now the product formed is called, we can write CH3. The hydrogen will shift it to here. Now the product formed is called CH3, CHCl2. This is Zem dihalides. The structure for Zem dihalides are nothing but we can write. This is CH3, CH bond Cl, bond Cl. You can write it as, or you can write it as in this form. There is bond Cl, then bond Cl, or you can write CH3, CHCl2. Whatever may be that methods we can write. Or else the same compound we can write it as in this form of CH3, CHCl, CHCl. All are in the same mode and all are to be the same structures. Now you are very clear with that. How do we prepare the Zem dihalides? You have to take that acetaldehyde and then treat it with PCl5. Now the compound formed is called Zem dihalides. That is nothing but ethylene dichloride, or it is 1,1 dichloroethane. Dichloroethane. This is a point you can write. And the another methods we can write the same preparations, that is from same compound which we can prepare from different reactants, namely acetylene gas and as well as hydrochloric acid. Now the product formed is called vinyl chloride. This is an intermediate compound. This intermediate compound is again it is treated with, that is that HCl. Now the product formed is called ethylene chloride. The same ethylene chloride. Ethylene dichloride is formed. Now just we have completed this preparation of Zem dihalides. Next we can go for the that is vinyl dihalides. Vinyl halides, you see here the example I am going to give, the first example, CH2 bond CH2, then Cl bond, then Cl, or we can write there is Cl bond CH2, then CH2Cl. You can write, otherwise this is nothing but we can write, you see two carbons are there, so you can write ethane. And how many chlorines are there? 2 chlorine, 1 chlorine from first carbon, another chlorine from second carbon. So you write 1,2 hyphen dichloroethane is its a UPC name. But its common name you can write, you see ethylene structure is there. So we can write ethylene dichloride. Ethylene dichloride is its common name. Common name, please understand. This is common name. Ethylene dichloride. It is 1,2 dichloro. Ethane is the IUPAC name. Now another structures I am going to give for that as an example. Now you write CH3, then you can write CH3, then CH bond Cl, then CH2. Here Cl. What's the concept you should understand? The halogens are present in adjacent. These two carbons are adjacent carbon. These two carbons are adjacent carbon. These two carbons are called adjacent carbon. Now this is the concept you can understand that 3 carbons are here, 1, 2, 3. Now the propane is the fundamental. Propane. Now how many chlorines are there? 2 chlorines are there. That is dichloro. Now where there is a chlorine present in first carbon and second carbon, you write now there is 1,2 dichloro. 1,2 dichloro. The propane is the fundamental. This is what is the number of carbon which is present in the straight chain. 3 carbons are there, propane. 1 carbon, you know that meth. 2 carbon, you know that eth. 3 carbon, you know that prof. 4 carbon, you know that bute. This is the fundamental. So now there is a propane, is the compound. So how do we distinguish from these vinyl halides and Zem dihalides? Zem dihalides generally, just you can come to know again, there is a Zem dihalides. How to distinguish this point? Actually, I am going to give one more example. You see, this is CH3, Cl bond, Cl, then CH3. This is called, we can say, isopropylidene chloride, we can say. This is called isopropylidene chloride. So, lidene, propylidene, you see here, ethylidene, propylidene, all are called, we say, Zem dihalides. All are called Zem dihalides. Now in this case, how to write this common name and IUPAC name? You see here that IUPAC 1, 2, 3. In second carbon, there are two halogens are present. Now you write 2, 2 hyphen dichloro. That is straight chain. What should be containing? 3 carbons. So propane is the IUPAC. What's the common name? You write now. Isopropylidene chloride is the common name. Is a common name. Isopropylidene chloride is a common name. 2,2 dichloropropane is the IUPAC name. So there you should have that distinguishing point about what is called Zem dihalides and what are called as vicinal halides. The vicinal halides are nothing but adjacent carbonated halogens are present adjacent. The Zem dihalides are nothing but the two halogen atoms are present in same carbon atoms. Two halogens present in same carbon atom. This is a distinguishing point. Two halogen atoms are present in the same carbon atoms are called, we can say, Zem dihalides. How do we prepare these Zem dihalides? How to name these? You are very clear. Next we are going for the preparation of vicinal dihalides. We have to go for the preparation of vicinal dihalides. The vicinal dihalides are nothing but just which containing two halogens. How to prepare these compounds? It is a simple methods of the preparations which we are going to see here. The simple methods of preparations. Now you see there is preparations of vicinal dihalides. Preparations methods of vicinal dihalides. The first technique we have to take, there is ethylene gas, that it is treated with chlorine. Now there should be a simple additions. You know how this chlorine can split into Cl bond Cl. Now I have given the idea there should be a double bond and triple bond. There must be a resonance, that is shifting of electrons. And this shifting of electrons, 2 becomes minus, 2 becomes plus. Now there is also the shifting of electron, 1 become minus, 1 become plus. The electron which is drawn is negative charge, carrying negative charge. And there is an electron which is lost to any atoms or to be carried as positive charge. Now these all to be approaches to this negative part and positive part. Positive part to negative part, negative part to positive part. Now the product formed is called, we can write CH2 bond, CH2, then Cl, is called ethylene dichloride. Ethylene dichloride. This is nothing but ethylene dichloride. The second methods which we are going to see here, the same. There is a concept which we are going to see here. Ethylene glycol. You take now ethylene glycol. This compound name is ethylene glycol. Alcohol. This is alcohol. Now treat with that halogenating halogenating agents like PCl5. Now what happened here? This PCl5 is having ability to remove the OH groups. How far this splitting will take place? You know that PCl5 can split into PCl3 and Cl and Cl. Now what happened? One chlorine will approaches to the hydrogen and this oxygen approaches to the POCl3. Now this halogen, that is chlorine, will approaches to this carbon. Now the compound form is called, we can write CH2OH, then CH2Cl, then POCl3 plus HCl plus HCl plus HCl. Now there is a second step which we are going to see here for this same compound, but this is not given in our book. These steps are directly given. You have to follow these steps for your learning aspect. Now I am going to give the second step, CH2OH, then CHCl, that is CH2Cl, then plus again PCl5. The PCl5 is split as such as here in this case. Now what happened again? The CH2Cl, then CH2Cl, then POCl3, then HCl, then plus HCl. This is a compound which is formed. This is nothing but, we can say, ethylene dichloride. This is ethylene dichloride. It is prepared by using two techniques. That is preparation of vicinal dihalides, and here ethylene dichloride, here also ethylene dichloride. This is also ethylene dichloride preparations. Next we are going to see what are the physical properties of these halides. What are the physical properties of these halides? What are the physical properties of these all halides? Physical properties. Generally, the physical properties are nothing but we are going to observe the smell of the gas and we are going to taste the compounds. We are going to analyze this boiling point, melting point. This is nothing but we can study it as physical properties. Now in this case of the halogens, physical properties of that polyhalides. Generally, gem dihalides and vicinal dihalides. The first thing you should know, these all to be sweet smelling liquids. Sweet smelling liquids, which are all sweet smelling liquids. Generally, which are all having higher boiling points. Higher boiling points. But comparing to these zem dihalides and vicinal halides, zem dihalides are having greater boiling points. Greater boiling point than that of vicinal dihalides. Halides. This is the concept of what is the physical properties, which are having sweet smelling liquids, sweet smell, and also to be in the form of liquids, which are generally having higher boiling points. Comparing these two, which is having higher boiling point than that of vicinal dihalides. This is a simple concept you should understand about these physical properties. Next we can go for the chemical properties of these all two halogens. Chemical properties. Zem dihalides and vicinal dihalides. gem dihalides and vicinal dihalides. The first thing, we are going to see the first example. Here you have to take gem dihalides CH3, CH, bond Cl, Cl. Now there should be this is the compound of ethylene dichloride. Ethylene dichloride is treated with, there is an aqueous KOH. Aqueous KOH. This aqueous means this is dilute in nature. The dilute KOH can split into K plus and OH minus. That here, in this case, chlorine to be also become as Cl minus. In this chlorine also to be become as Cl minus. Now there should be a 2 chlorines. There is a 2 chlorine and you have to take 2 KOH. 2 potassium, 2 positive charge will leads to form, that is 2 KCl. 2 KCl. This is a compound, 2 KCl. Then plus the compound which is formed is called, we can write, and this OH minus, this one minus is going out. This is nothing but, we can say, minus is nothing but in chemistry it is nucleophile. This nucleophile is going to remove by this another nucleophile. One nucleophile is to be disturbed by, is to be substituted by that another nucleophile. Is nothing but nucleophilic substitution reactions. Now 2 OHs all get to be substituted. Finally, we will get the product of CH3 CHOH. Now there is a conditions. 2 OHs are at present in the same coordinate term. This is called diols, dialcohols. That means dialcohol, ethylene diols. This is to be unstable compound. Unstable compound. And this generate and water molecules. Now the bonds shifted to here. What happened here? There is a bond between hydrogen and oxygen. Now the compound formed is called CH3 double bond OH plus H2. Actually this is called, acetaldehyde is generated and it is formed. Actually, from this acetaldehyde only we have prepared these gem dihalides by passing PCl5. You know that in preparations, first preparations we have seen. This is that question paper. That is to be that question which is asking in your examination, either NEET or to be in state board examination. First it is to be generated, and here this compound is the diol which is generated from this ethylene chloride. Now this is to be unstable. Now the product which is formed is called acetaldehyde. You see that second chemical properties that we are going to treat it with zinc bar alcohol, namely methanol. The same compound we are going to take here. This is CH3 CHCl2, then plus zinc for methanol. What happened here? The zinc is greater electropositive, that it can affinate that halogens. It can affinate the halogens. Now what's the product which is formed is, we can write, there is CH2 double bond CH2 then plus ZnCl2 will be formed. Actually, what's the reaction which is taking place here? The hydrogen will shift to here one hydrogen. That means in CH3, one hydrogen to be shifted to here. The 2 chlorine is affinited by this zinc to form as a zinc dichloride. Now this compound formed is called ethylene. This is ethylene. Next we are going to see this is a reaction 1, this is a reaction 2. We can write ethylene dichloride. Then plus the same zinc bar methanol. Zinc bar methanol. The product formed is called, this halogen also be affinited by the zinc. This halogen also be affinited by the zinc. The same compound of ZnCl2 will be formed. Now what is remaining? Actually here that CH2 double bond CH2, this is called ethylene, you know that. In both Zem dihalides, this is vicinal halides, both are giving Zem dihalides and vicinal dihalides, both are giving the same ethylene gas, in this case of zinc by methanol. KOH, which is we are taking here for this reaction. Now the first reaction, I am going to give for this CH3, CHCl, in presence of alcoholic KOH. This reaction is otherwise known as dehydrohalogenation. Dehydrohalogenation. That means there should be a removal of waters. Of H2, and also there should be a removal of halogens. Both are taking place simultaneous process. These two are going to remove simultaneously. This is simultaneous process. This is simultaneous process. Now you take this alcoholic KOH. I am giving this separately, this reaction. You write, you see, you follow me. CH3, CHCl, CHCl, then plus there is alcoholic KOH. That is, see here, this hydrogen to be forms as H plus. This hydrogen. Now I can write it as in this form. H and H. Now this is that also bond with that hydrogen, This can forms as H plus. This also can forms as H plus. Now these two H pluses. Now you take, there is 2 moles. Now you see here there is a 2 halogens. What's the point? What's the concept in this reaction? This is dehydrohalogenation. There should be a removal of waters. You see this 1 H plus and here 1 OH minus. Here 1 H plus and here another OH minus. This all together produces 2H2. Now next we are going to see here the compound. What is here? The one bond shifted to here, the another bond also to be shifted to here. Now the final product formed is called, we can write, you see CH, triple bond CH. You see CH, this one bond, triple bond CH. This halogen also to be removed. Now the product formed is called 2KCl. That's all. Now this is called acetylene gas. This is called acetylene gas. Now this is called acetylene gas. Now there's another reactions which we are going to see here. The another reactions. That is from the another reactions. The another reactions which we are going to see here. The same, this is, we can say, Zem dihalides. Now we are going to see here vicinal halides, the second one. CH2Cl bond, CH2Cl bond, this is vicinal dihalides. Also to be treated with alcoholic KOH. This is also, this reagent is act as a dehydrohalogenation. Dehydrohalogenation. Now the product form, what is called? You know that there is a hydrogen to be going to remove as H plus. This hydrogen also to be going to remove as H plus. Now this halogen are going to remove as an Cl minus, Cl minus. Now finally the same compound which is to be going to form CH triple bond CH, that is plus KCl, that is 2 KCl, that is plus 2H2. This is the concept of dehydrohalogenations. This is nothing but we can write acetylene gas. It's a point. There are the concept which you are going to see here, the chemical properties. There are the three chemical properties we have seen. The first chemical properties, that is I have represented as A, is called aqueous KOH. The second chemical properties is just it is treated with the halogens, that is Cl2. The first chemical properties, A I have represented as, that is aqueous KOH. The second chemical properties, that is zinc methanol. And the third chemical properties, that is alcoholic KOH. This is the chemical properties we have seen. Next we are going to see this, the third compound. What is called the third compound? What is called? This is methylene dichloride. Methylene dichloride. You know the structure for methylene dichloride, CH2Cl2 is the methylene dichloride and its structure. Methylene dichloride. Dear students, just we have completed something about this, what is polyhalides and what's the classifications and what is the naming system and what are the polyhalides in organic compounds and how do we prepare it and what are its physical properties and what are its chemical properties. All just I have completed in this session. The tomorrow session, just we are going to see that next compound, what is called methylene dichloride, how its preparations and its physical properties and its chemical properties and its uses and so on. We are going to complete this chapter tomorrow onwards. You please observe this video and you have to clarify these all concept what is given here in this board, and you have to read that your book thoroughly, and then if there is any doubt you please ask me. We will have to give the guidelines and ideas how to read this chemistry and how to learn the chemistry. Thank you. We will meet tomorrow.